Hi Math 1 students, today we're talking about the distance formula, slope, and Pythagorean theorem. Some of this should be a little bit of a review. So if I look at example 1, it says find the length of this segment, and there's two different ways we can do that, either the distance formula or the Pythagorean theorem. So if you look at the distance formula, it says we're going to want to use that when we have 2 points or endpoints of a segment. So if I look over here, what are my 2 endpoints? This is 0, -1, and this is -2, 5. So I'm just going to record that over here, -2, 5, 0, -1. It doesn't matter which point you put first and which point you put second. So if you look at the distance formula, it says d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to label this as x1, y1, x2, y2. So if I calculate my distance here, it's going to equal the square root of x2, which is 0, minus x1, so I'm going to say minus, and then notice x1 is -2, so we're going to put that in parentheses, squared. So in between the two is the subtraction sign, and then afterwards was a negative. So I'm going to put parentheses around that to indicate I'm going to have to use leave change. Plus y2 minus y1, so that would be -1 minus 5 squared. So now all I have to do is simplify. So 0 minus -2, that would be 0 plus 2, so that would be 2 squared. -1 minus 5, that would be -6 squared. Notice how I'm putting that -6 in parentheses. That is going to be incredibly important when you put that in the calculator. So So 2 squared is 4. -6 squared, so that's -6 times -6, that is 36. And then 4 plus 36 is 40. So the distance is square root 40. To get that as a decimal in your calculator, hit second x squared and then type in 40. So it should give you approximately 6.3 units. So this was finding the length of the segment given the 2 endpoints. So I was given the 2 ordered pairs. So if I look at the Pythagorean theorem is another way to find the length of a segment. So Pythagorean theorem only works in right triangles, and we're going to use it whenever we're given a graph of a segment. So if I kind of zoom in here, if it only works in right triangles, we're going to essentially have to make a right triangle with this segment. So I'm just going to draw a vertical dashed line and then a horizontal line, and where they meet there is a right angle. So essentially we have made a right triangle by connecting the vertical components with the horizontal. So the Pythagorean theorem states c squared equals a squared plus b squared. So c squared is the hypotenuse. That's always your longest side across from your right angle. And when we're in a grid like this, it's always going to be this slanted piece. So that is my hypotenuse. The other 2 sides are called legs. So this is a leg and this is a leg. Okay? So we need to do the hypotenuse squared equals the leg squared plus a leg squared. So I don't know the length of the hypotenuse, so I'm just going to put x to represent that length. So we're going to say x squared equals. So now we're going to have to find the lengths of the legs. It should be pretty simple if it's on a grid. I can essentially just count how many boxes I have to represent each side of the triangle. So if I count from -2, 5, I would count 1, 2, 3, 4, 5, 6. And then if I count this horizontal side, 1, 2, so that tells me I have a leg of length 6 and a leg of length 2. So it doesn't matter if you put the 6 in first or the 2, it would be the same answer. So you could say 2 squared plus 6 squared, or 6 squared plus 2 squared. All right, after this we're going to simplify. 2 squared is 4, so I'm going to say x squared equals 4. 6 squared is 36. 36 plus 4 would give us 40. So the goal was to find the length of that segment, which was the hypotenuse in this right triangle. So if you look, we're trying to find x. Right now this says x squared. So to undo that squared to get x alone, we're going to have to use the inverse of a square, which is a square root. So I'm going to square root both sides, so that would essentially just give me x equals square root 40, which we said was approximately 6.3 units. So if I look here, the distance formula and the Pythagorean theorem gave me the same answers because the Pythagorean theorem, or the distance formula, is derived from the Pythagorean theorem. All right, the next problem, we are going to find the slope. So the two ways to find slope we should know are the slope formula and using a graph, rise over run. So if I'm using the same ordered pairs as I did in the last problem, so it says -2, 5, 0, -1. So if I label this x1, y1, x2, y2, remember, y's always go on top. So we're going to say y2 minus y1 divided by x2 minus x1. So y2 is -1 minus y1, which is 5, over x2, which is 0, minus x1, which is... So -1 minus 5, that would give me -6. 0 plus 2, when I do leave, change, that would give me +2. So my slope is -6 over 2, which would reduce to -3. So that's a refresher on the slope formula. If we're talking about rise over run, remember, you're just going to start with one ordered pair. I'm going to start with 0, -1. So how much do I have to rise? 1, 2, 3, 4, 5, 6. So since I was going up 6, it would be a +6. And then, so that tells me my numerator is 6. And run, I have to go to the left 2. Since we're going to the left 2, remember that would be a -2. So our slope is -3. So we got the same answer if we use the formula or the graph. So if I look at this next problem, it says find the length and the slope of a given line. Since there's a graph here, I'm going to use Pythagorean theorem and the slope rise over run. So remember, if there's a graph, you can easily make this into a right triangle. So I just have to connect this horizontally and vertically. So I'm going to start with this point here. And so I'm going to say 1, 2, 3, 4. So this side would be 4. And then 1, 2, 3, 4, 5, 6, 7, 8. So the length of this side of the right triangle would be 8. I'm just talking about the lengths of the sides, so I would use positive numbers. So c squared, that's the unknown. So I'm going to say x squared equals 4 squared plus 8 squared. Remember, it doesn't matter if it's 8 squared plus 4 squared or 4 squared plus 8 squared. So 4 squared is 16. 8 squared is 64. When you add 16 plus 64, you get 80. So remember, to undo that square, we're going to take the square root. So x would be approximately, if you type that in your calculator, 8.9 units. So the length of this segment is about 8.9 units long. So when we're talking slope, slope is rise over run. This is when you have to make sure you're paying attention to the signs. So if I started at this point, I have to move down 4. So what should be in front of this 4? A negative sign. And then I would have to move left 8. So that would be another negative. So my slope here is a negative 4 over negative 8, which would reduce to a negative divided by a negative. So that would be a positive 1/2. Okay. So since we had a graph, we used the Pythagorean theorem in the slope. Rise over run. Look at example 4. It says find the length of the slope of a segment given its 2 endpoints. So this gives me 2 ordered pairs. So I'm going to use the distance formula and the slope formula for both. To find the length, we're going to use the distance formula, and then this formula, the slope formula, would help me find the slope. So I'm going to plug this into my distance formula. So I'm going to say d equals the square root, big old square root symbol, x2 minus x1. So x2 is negative 16 minus x1, which is 14 squared. And then we could say y2 minus y1, so plus, and then y2 minus y1, so that would be negative 8 minus, and then y1 is 2 squared. All right, so now we need to simplify what's in the parentheses. So negative 16 minus 14, so that would give you negative 30 squared. Negative 8 minus 2, so that would be negative 10 squared. Notice I have parentheses around them, so when you type it in the calculator, make sure you use the parentheses. So negative 30 squared is 900. Negative 10 squared is 100. So when you add those two together, you get 1,000. So this would be the square root of 1,000. So the distance would be approximately 31.6 units. So the segment with those 2 endpoints would have a distance of approximately, a length of approximately 31.6 units. For the slope, do you notice how y2 minus y1 is right here in the distance formula? And then x2 minus x1 is right here in the distance formula. So I can just essentially grab the numbers from the formula over here. I know the second part is always going to be my y2 minus y1. So if I look, that simplifies to give me negative 10. So in the numerator, I could say negative 10. Because I already did the calculation, negative 8 minus 2. If I look here, I could, in the denominator, write negative 16 minus 14, but we already figured out that that is negative 30. So you can use, the components are in both, so you can use that to kind of streamline this process a little bit. So negative 10 over negative 30, that would be a positive 1/3. All right. For the last problem, I want you to pause the video and try it on your own. When you're ready to check your answers, hit play. And here are your answers. So for number 1, you should have had the Pythagorean theorem, done the Pythagorean theorem to get the length was 5 units. The slope was negative 3 over 4. Number 2, the distance was approximately 7.2 units, and the slope was negative 2/3.